Hello, my name is Jonathan Loughrey. I'm here today to talk to you about the single crystal X-ray diffraction service that we offer here at Solid Form Solutions. So first off, I'd like to talk to you about why single crystal X-ray diffraction is important. We use single crystal X-ray diffraction to provide confirmation of connectivity and absolute configuration, for example chirality, of any compound of interest. Compounds which may be investigated by our service include API, degradants and impurities, novel polymorphs and solvates, co-crystals and salts. Structures collected by single crystal X-ray diffraction are interrogated to provide key structural information regarding packing of molecules in the solid state, solvent voids and any potential hydrogen bond donors or acceptors. This information may then lead to the scientist to investigate and avoid particular solvents wherein the risk of forming novel polymorphs or solvates is high, but may also lead to the potential of engineering suitable morphologies. This is particularly useful when we end up with a polymorph which may give us a morphology such as a needle. Here are a few examples of structures from my past, my academic past. And what we have in the top left example is a rather large molecule. This contains a metal site right in the center and two identical ligands. We also have a very small molecule which is chiral in the top right. Again, a larger chiral molecule in the bottom left, and on the right hand side an even larger still chiral molecule, purely organic, but in this case contains a small dichloromethane molecule. When we look at the structure in its extended lattice, what we see is that this dichloromethane molecule is located in small solvent pockets. This is just a small snapshot of the service that we can offer at Solid Form Solutions, where we can locate solvent molecules which may or may not be of interest, and potentially avoid these kind of solvates. What to expect from a work program here at Solid Form Solutions for the single crystal side is when we have found suitable crystals, these are then analysed by an X-ray diffractometer and the data is always held in the strictest confidence. The structures are then solved by an in-house crystallographer, myself, and initial structural results are then communicated immediately via slide pack and teleconference. Later on, a full written report is then issued containing full experimental details, including salt formation, if appropriate, or crystal growth. Unit cell metrics, including the empirical formula, for example, if there is solvent held within the lattice, we can give you a full stoichiometric or non-stoichiometric solvent content. Detailed structural analysis, including bond lengths and moiety conformations, which may be useful, say we have something in a chair conformation. Full IUPAC name generation, including absolute configuration wherever appropriate. Simulated reference X-ray powder diffractor 2θ diffractograms for later use, say for manufacture batches if it's of use. Complete crystallographic information file, so the CIF file for use in later regulatory or publishing purposes. Recommendations for further work and analysis of risk regarding choice of solvents and or salt. This is particularly useful where you may want to avoid potential hydrogen bond donors or potential solvent voids, which then can be occupied by a wide variety of different solvents. And then once complete, I myself, the SFS Crystallographer, is always available to discuss the results obtained and discuss anything in further detail via telephone. So thank you for watching this short video. Our contact details are there in the bottom right hand side. Please do get in touch should you be interested in our service. Thank you.